Hello, my project is on routing and scheduling of crude oil tankers. These projects explain these contents which are given in this table of content, and in the end it concludes and tells the future work required in this particular project. As the demand of petroleum products increases, the supply chain of petroleum shipping industry become more complex. This project illustrates how the concept of distribution management can be applied to this supply chain. It also shows how different countries benefit from importing crude oils from different locations depending on the various criteria. The main objective of the project is to reduce the price of crude oil products throughout the country. It is important to minimize the cost of transportation of crude oil as much as possible. The supply chain cost of crude oil tankers primarily depends on the following factors: cost to ship 1 barrel of crude oil per 1000 nautical miles, time taken to ship crude oil from its source to the destination, distance from the source to the destinations, cost of crude oil tanker if rented or leased, cost associated with employees working on crude oil tankers, cost of fuel used up to ship the crude oil. 15 cities around the world are selected randomly as importer of crude oil, and 5 major oil exporting cities are selected and they are acting as depots. The time windows are taken precisely by calculating the minimum time and maximum time required to reach the crude oil tanker from its source to the destination. Capacities are taken in chronological order of oil reserve in specific cities. The demand of the importing cities are taken randomly. Also, $1 is the cost of shipping 1 barrel of crude oil for 1000 nautical miles. Among 7 to 8 research papers on crude oil tanker shipping, the 3 research papers which helped me to understand the concept of my project were these 3. This research paper gave me an understanding of hard time windows for the tanker fleet for delivering the extracted crude oil from near seashores to the nearby storage facilities. This research paper gives a few extra constraints which deal with multiple pickups and multiple deliveries of petroleum product or crude oil in most cases. But in my project, I use the concept of multiple deliveries from a single pickup. This research paper helped me to formulate the continuous time windows and multiple destination models. The distance between the two nodes are calculated by this formula, and the unit of the distance is in nautical miles. Assignment algorithm assigns each tanker to different cities, or in some cases subtour elimination constraint eliminates the repeated tour or the same city. The capacity constraint gives the amount of crude oil left in the tanker at any given node. All tankers have different capacities at different nodes. The vehicle ID constraint is helping to track the tankers and its route. It simply checks the entering tanker on the node I and leaving tanker from the same node. And thus continuing this cycle, it tracks the whole route of the tankers. The time window constraint ensures that the start time of the task should be less than the latest start time and greater than the earliest start time. The solution technique of this particular project is quite simple, which was already taught by Dr. Cyrus. In the first, the assignment algorithm is executed. Next, the subtours are eliminated. Then the capacities are satisfied based on the capacities constraint. Then the vehicle IDs are generated so that we know which vehicle is going on which particular node. Then the time windows are satisfied. In the end, the minimization of cost is achieved. This overall model was solved in OpenSolver, which is the Microsoft Excel's add-in. The part of experimenting with the model is done quite logically in this particular project. We know that due to war between Ukraine and Russia, the price of petroleum products increased significantly. But how exactly supply chain is getting affected? Take these data sets with where demand is random but the capacity from St. Petersburg is kept large when compared to other cities. So by solving this, we get $1.8 million as our minimum cost. In the next case, we reduce the capacity of crude oil from Russia and distribute the remaining capacity to other oil exporting cities in Asia. Keeping the demand constant around the world, we can see an increase in minimum cost objective, which is now became $1.97 million. Thus, we can say that when Russia decided to cut off its oil supply or reduce its oil supply to the rest of the world, the price rose significantly because of the cost associated with the supply chain of petroleum product increased. Obviously, the price increase depend upon other political and economical reasons, but from supply chain point of view, this increase in cost was inevitable. When the first dataset of distance matrix, cost matrix, capacities, and time windows are taken into consideration, we get a specific route, which is shown in this figure, where the node 16, 17, 18, 19, 20 are the exporting countries and rest of the nodes are the importing countries. Therefore, the model formulated in this particular project successfully runs and demand of the crude oil from the importing countries are met by the exporting countries. This project studies routing and scheduling of crude oil tankers and propose an integer programming model to solve. This project is a simple form of real life problem petroleum industries are facing. In addition, I must admit that there is still much more room for further improvement in this particular project. For instance, there are many more aspects which need to be considered while formulating the model. Some aspects are split pickups, some pipelines, storage duration control, overage, demurrage, etc. The realistic consideration of demand and cost would bring optimization closer to the real world situation. So overall, this was my project. Thank you. These are the references which I used in the project. You can go through it if required. Thank you.